Okay, guys, so welcome to this part of lecture wherein we are going to learn about Vigenere coding, which is another form of classic cryptography. Okay, so Vigenere coding, I don't want you guys to get confused. It's nothing but another complex form of Caesar cipher, guys. Okay, so if you remember my lecture from Caesar cipher, it used to encrypt a plain text or the original text by using the technique of shifting of letters by some known number of positions, guys. Okay, so if you remember that part, okay, so it would be very easy for you to understand this Vigenere coding. Okay, so Vigenere coding is nothing but it's a complex form of the Caesar cipher coding. Okay, and it actually involves use of a keyword or a key, guys. Okay, now how that is all used together, we are going to see a live example. Okay, and in the next slide. Okay, so for the time being you can just consider it to be a very complex form of Caesar coding, and it is also known as poly-alphabetic substitution. Okay, because it does not involve substituting a single letter, okay, by just moving it through some known number of positions, but over here the number of positions through which a letter is moved, it's actually variable, guys. Okay, so it's not fixed. So in Caesar cipher we saw that throughout the entire cipher the sender of the message shifts any letter by some known position, guys, like say 2 or 3 or 4. Okay, and it remains fixed throughout the entire message. Okay, so if the message is cat that we I am trying to encrypt, so if C is moved by 2 positions, then A would also be moved by 2 position. T is also would be moved by 2 positions. Okay, but in Vigenere coding, the number of positions that a letter would be moved in the plain message or the original message is actually variable, guys. Okay, and it depends upon a complex method that I am going to demonstrate in the next slide, guys. Okay, so I think this part is clear for you all, guys. So let's move on to an actual example. Okay, so in this example, guys, okay, I have a plain text, okay, which is Sumitavo, which is my name, okay, and as I told you in the last slide, that Vigenere coding involves usage of a keyword, okay, and the keyword is nothing but a random word, okay, that is used actually for this purpose. Okay, and this keyword would be actually pre-decided between the sender of the message and the recipient of the message. And how we derive the ciphertext, let's look into this example. Okay, so for this I would like to bring out the laser pointer at this point of time. Okay, so yeah, so guys, first of all, for Vigenere coding, we need a table like this. Okay, now this table, although it looks complex, but it is very easy to form. Okay, so on the rows you can write A B C D till Z. Okay, then on the vertical column you have A to Z again. Okay, and inside it also the first row is A to Z, guys, as you can see. Okay, now the next row is shifted by one letter. Okay, so you can see that in the first row A was here. Okay, but here we have B. Then as usual we move towards Z. Okay, but the A that was over here, guys, okay, that has moved towards the back. Okay, now again you can see that in the next row we have C here. Okay, then as usual the letter column follows, and we have AB here. Okay, so whatever moves from here to here, it's come back from here, guys. Okay, so like that way you can see that finally A comes back again to here. Okay, with the exception of this letter Z over here. Okay, so it's a cyclic kind of a table, guys. Okay, and you can easily find out a pattern. Okay, now coming to the way of encoding it, so the first thing that to consider is that we have to have a keyword here, okay, which is just like a key that is shared between the sender of the message and the recipient of the message, guys. Okay, so what happens is that, first of all, if the keyword is a small number of characters, okay, like over here it's 3 characters, we have to repeat this keyword until it matches the length of the plain text that you are trying to encrypt, guys. Okay, so over here you can say, see that Sumitavo is a number. How many characters are there? 1 2 3 4 5 6 7 8, 8 characters. So you can see over here cat word is repeated so that it reaches a length of 8 characters, guys. Okay, so now coming to how it is encrypted, the way is that the letter of the plain text is the one that you have to search in this column, guys. Okay, and the letter of the keyword you have to search in this row, okay, that you are seeing here. So I'm repeating it again. The letter of the plain text you have to search in this column, guys. Okay, and the letter of the keyword you have to search in this row, guys. Okay, now let's see how we arrive at this cipher text using Vigenere coding, which is our encoded message actually. So first thing is the letter S. How do we encrypt that, or how do we generate a cipher out of it? Okay, so S, as I told you, that we have to search in this column. So over here S is here, guys. Okay, you can see S here. Okay, now the corresponding letter in the keyword is C. Okay, which is C here. Okay, so S and C. Okay, so if you see that C is here, guys. Okay, C of the keyword is here. So let's match these two things and arrive at the character. So we have to match S with C, which arrives at U, guys, here. Okay, so S and C arrives at U because C is here in this row. Okay, and S is in this column, so we arrive at letter U. So U becomes our cipher text. Okay, next letter in the plain text is U. So U matches with A. Okay, so let's find U here in this column, and we have to find A in this column, guys. Okay, so when you match U and A, you arrive at U again, guys. So that's why I put U text here, cipher text here. Okay, next letter in the plain text is M, guys. Okay, so where we have to find M, guys? We have to find it here. Okay, so M is here. Okay, and the corresponding letter in the keyword is T. Okay, so where is T in this column, guys? It is here. Okay, so let's match T with M here. Okay, and let's see which character it arrives. So I'm moving, I'm moving, I'm moving, I'm moving, and I finally come here. Okay, so you can see this F letter is corresponding to the T. Okay, and the M here. Okay, so we have arrived at the letter F. So F becomes our third cipher text word. Okay, so in this way, guys, if you repeat this example, you will find that UUFKTTXO is the Vigenere cipher text corresponding to the plain text Sumitavo. Okay, and since this keyword is known by by the sender as well as the recipient of the message, so the recipient, when he receives this cipher text, he or she can actually decrypt it back, okay, to the original text, guys, using this table. So guys, I think you are clear on how Vigenere coding is working, and you can know by now that it's nothing but just a complex form of Caesar cipher and more difficult to break. So that was actually generally the purpose, that with as the time evolved, okay, as cryptography evolved, people were trying desperately to develop complex methods of cryptography, which is very difficult for the opponent or for the adversary to break. So that actually led to an eventual evolution of cryptography, and Vigenere coding is one example of that. Okay, and it was primarily, guys, used in the 15th century, around to 15th century. Okay, so that's it, guys, for this lecture. If you have any doubts, okay, do let me know in the question and answer section. Else please feel free to move into the next lecture. Thank you, guys.